All right, new definitions, cardinality and equivalent sets. The cardinal number of a set is the number of distinct elements in a set. So cardinal numbers, basically how many numbers are in the set, but this word right here is very important, the number of distinct elements in the set. So set A, that contains 1, 2, 3, 4, 5, has 5 elements because there's 1, 2, 3, 4, 5 distinct elements in that set. So we say in words the cardinal number of 5, or we say it has cardinality 5, and the symbol for this is n parenthesis capital A, and that is read n of A. So when you see that, you know we're talking about the number of elements in the set. So the cardinal number of this, there's 1, 2, 3, 4 elements in that set. So the cardinal number of set A is 4. B is the set that contains 0. How many elements are in there? 1. I don't know if Math Excel is going to ask you to actually type in n of A and then you have the 1, or they may already have the n of A and all you have to type in is 1. It just depends on the problem. This is where you got to be careful. You look at this and go, oh, I see 5 things sitting there. But remember that word distinct. We don't really need to repeat the 1. We don't need to repeat that 2. So how many distinct elements are here? 3. Set D is the empty set. How many elements are in the empty set? None. So its cardinality is 0. Equivalent sets. The word equivalent is referring to 2 sets having the same number of elements. And in terms of the cardinality representation, we would say n of A equals n of B. Equivalent means the same number of elements. So let's say set A in set builder notation is all x such that x is a vowel. Well, let's write it out in roster method. That's A, E, I, O, U. Set B is all x, where x is an element of the naturals, and x is between 3 and 7. Notice less than or equal to 3 means 3 is going to start my set. 4, 5, 6. Include the 7 or not? Yes. Now, how many elements are here? There are 5. How many elements are here? There are 5. So we would say that these 2 sets, at set A and set B, are equivalent because they have the same number of elements. Now, when you have the same number of elements, you can line them up and kind of correspond, like A goes with 3, E goes with 4, I goes with 5, O with 6, and U with 7. These lines with arrowheads indicate that each element of set A can be paired with exactly one element of set B, and going the other way, each element of set B can be paired with exactly one element of set A. And we call this a one-to-one correspondence. That term makes sense, one-to-one, because for one element in this set, it's being paired with one element in that set. So let's say we're in a classroom and there's 40 seats in the room and every seat is filled. This means there is a one-to-one correspondence between the seats in the room and the students in the class. 2 new words. Finite set is a set with a defined number of elements. In other words, it's a set that ends. So 1, 2, 3, 4 is a finite set. An infinite set is a set with an infinite number of elements. N equals the natural numbers is an infinite set because it continues on and on. 2 sets can be equal, and 2 sets are equal only if set A and set B contain exactly the same elements. We're not talking number of elements, we're talking exactly the same elements, regardless of order or possible repetition of elements. And in symbols, we just do A equals B. So are these 2 sets equal? Well, let's see. Here's 1, there's 1. 2, there's 2. 3, there's 3. 4, there's 4. Bingo, same exact elements. So we would say set A equals set B. It doesn't matter about the order, and it wouldn't matter if set B had actually been B equals 1, 2, 3, 4, because that 1 did not need to be repeated.